Hello students, today I am taking the 14th chapter, the atomic model or the atomic physics. Atomic physics. Now in this chapter we will see the different models given by different scientists, their success and their failure, and finally the hydrogen spectrum. That was the burning topic of that time. After the discovery of electron and proton, it was thought that there must be something. The distribution of electrons and the positive charge inside the atom. So, keeping this in mind, first model was given by J. Thompson, called the Thompson atomic model or plum pudding model. Thompson atomic model. Thompson was the first scientist who discovered the presence of electrons in the atom, and then it was found that there is the positive charge also in the equal amount as the charge, total charge of the electrons, because atom is neutral. So it was thought that some atomic structure must be given to explain the different phenomena related with the atomic theory of the substances. So, or one another name is given to it, plum pudding model. Plum pudding, this is the name of the sweet where the plums are attached with the sweet in different points. So it was thought that this may be kind of this one. Later on, it was also compared with the structure of the watermelon. So according to Thompson, the atom is just like a rigid sphere. The atom is indivisible. It means that it cannot be divided into different parts. The electrons are distributed in atom like plums in pudding sheet. Or like the seeds in watermelon. The positive charge in atom is just like liquid or the water in watermelon. So positive charge is uniformly distributed. Is distributed in whole of the atom. Since atom is neutral, so Thompson said that the total positive charge of electrons is equal to the total negative charge of the electrons is equal to the total positive charge spread in the atom. Since atom is neutral, so total negative charge due to electrons is equal to the total positive charge spread inside in the atom. It means that the electron may be anywhere inside the atom and the whole of the charge is evenly distributed inside the atom. So it takes the model like this. Suppose this is the atom. The electrons are like this. And this space is filled with positive liquid charge. This is the atom. This is electron, and whatever you see here, this is the positive charged liquid. This model actually has so many discrepancies and it was not the successful one. But at that time there was two things. One, the thermionic emission of electrons, and second, the hydrogen spectrum. This model could successfully explain the thermionic emission just by comparing that, this phenomena as the vaporization of the liquid or water. When the water is heated or liquid is heated, then it converts into the vapors. The atoms get so much higher energy that they leave the liquid and thus they goes out of it. So this phenomena, this model could successfully explain the thermionic emission of the electrons. But at the same time, there was the hydrogen spectrum. This model could not explain the hydrogen spectrum. The moving charge, he said that the moving charge also emits the electromagnetic radiations. It means that if this electron emit all these electrons are in the vibration position and they have equal vibrations, it means that they will emit the radiation of the same frequency. But in case of hydrogen spectrum, it was not so. There were many spectral lines which indicate that there are many frequencies that are emitted by the electron. So this could not be explained by this one. The electrons in atom are not at rest, but they vibrate with same frequency and emit the radiations. This was another thing that was given by the J.J. Thompson. Success of model Thompson model, Thompson's atomic model could successfully explain the thermionic emission of electrons from metals. This was a great success because at that time no one could explain the thermionic emission, but taking the help of this model, he could easily explain the thermionic emission of electrons. failure of the atom, atomic model. Since electrons in atom vibrate and emit radiations of same frequency, it means that the spectral line of single wavelength will be emitted by the. At that time, the burning topic was the spectrum of the hydrogen. In hydrogen spectrum, it was found that the atom emits the radiations of different wavelength. Since we are getting different a number of lines in the hydrogen spectrum, it could not explain the different spectral lines emitted by hydrogen atoms. In hydrogen spectrum, there were many spectral lines of different wavelength. Could not explain the different spectral lines emitted by hydrogen atom. In hydrogen spectrum, there were many spectral lines of different wavelength. So this atomic model was the totally failed. So this model failed to meet the spectral lines in hydrogen atom. Hydrogen spectrum. So this model was discarded. Hence, model was discarded. by scientists. So it was thought that something new model is required for this one. Moreover, there was no particular law of distribution of electrons, because in atom there is only hydrogen atom can have only one electron. Remaining all the atoms have higher number of electrons. So how can we distribute? There was no idea of the spectrum of the distribution of the atom of the electrons in the atomic model. Moreover, there was no rule for the distribution of electrons in the atoms of higher atomic number. Higher atomic number. So this model was totally discarded by the or rejected by the scientists. At the time of J.J. Thompson, the Thompson was a very eminent scientist. He has many students who always conducted something researches in the different fields in chemistry and physics also. In this team, he also had his son who was doing the research. Rutherford was one of them. And it was Rutherford who gave the different model from the J.J. Thompson's model. And for that he got the Nobel Prize also. So all his students studying with him, they all got the Nobel Prize either in physics or in chemistry. J.J. Thompson, a very eminent and very famous scientist of his time. So, on the next video, I will tell you about the Rutherford's discoveries. First, he conducted the alpha particle scattering from the gold foil. I will tell you that, and then the conclusions of the model of the experiment, and then he gave the model also. And he gave a very important thing, that was the concept of nucleus in the atom. So you like this video, share and subscribe to your friends who are studying in the same stream. Thank you.